Laws of surds 1.41. There are 3 laws of surds. 1. Root AB can also be written as root of A times root of B, which equals to root A root B. Let's do an example. Root of 12 can also be written as root of 4 times 3. So 4 is A and 3 is B, which can be root of 4 times root of 3. Root of 4 is 2, so that would be 2 root 3. Root of 18. By the way, root of 3 is a surd. The number, if I put it onto the calculator now, switch the calculator on, put root of 3, you can see, convert that to standard decimal, 1.7320, and it goes on. So it's a surd because it's a root of 3, which it just goes on forever. And so to be exact, we leave it as root 3, and this is 2 times surd, so it's 2 times root 3. Root of 18. So we always look for the largest square number. In the largest square number of 18 will be 9. So root of 9 times 2. And root of 9 times root of 2, which will become 3 root of 2. So root 18 is 3 root of 2. Could do another one. Root of 27 will be, again, we want to find the largest perfect square. So we want 9 times 3. The largest perfect square within 27 is 9. Goes, and then you can multiply by another number to get 27. So it's 9, and that would be root 9 times root of 3, and that will be 9. Root 9 is 3 times root of 3. So root 27 is 3 root 3. The second law is a division law. So if I have A over B whole square root, that can be written as root of A over root of B. Just like we did the first one, which is multiplication. A times B square root. That became root A times root B. Likewise, A divided by B square root A divided by root B. So, and that's the second law. Root of 3 over 16, and that will become root 3 over root 16, which is root 3 over 4. And you can write that as a quarter root of 3. Same thing. Root of 5 over 4, which is root 5 over root 4, which is root 5 over 2, which can also be written as a half times root 5. That's a quarter times root 3. Number 3, root, so a root of a squared. Root of a squared. When you square a square root, you will get root a times root a, which will become a. Now, we should be able to prove this because we've done indices. Remember the rule of indices, because let's try and prove that here. So we know in indices that root a can be written as a to power a half, a unit fraction power. Okay, so if we have a to power a half times a to power a half, we also know in the law of indices that a to power of n times a to power of m becomes a to power of n times m. So n and m, that will become a to power of a half plus a half, which is a to power. The fractions have same denominator, so you add it up. 1 plus 1 is 2 over 2, which is a to power of 1, which is a. So we've even been able to prove that because we have done indices before. So if you square root 3 squared will be 3, which is root 3 times root 3. One more thing, there is actually another important one that we could look at. So I better do that here. I'm going to call that the fourth one, which is, it's similar to the third one, but the fourth one, it's not exactly similar, but if you have two factors of Sod's expressions, so if I have a plus root b and I'm timesing it by a minus root b, so that's one important one. That would give us a times a would be a squared. A times minus root b would be minus a root b. So what I'm doing is, just to make sure I'm doing this properly, a times a is a squared. A times minus root b is minus a root b. Then I've got root b times a and root b again times minus root b. So that would be plus a root b times minus root b will be minus root b times root b. We know root b times root b will be b from our definition here, from the third law. Root a times root a is a. Root b times root b will be b. And so we will get a squared. Now, a root b and a plus minus a root b plus a root b will be 0. So they cancel out. So my final answer will be a squared b. This is one way of eliminating Sod by using its conjugate pair. So conjugate pair means that if I have a surd, which is a minus root of b, the conjugate of that surd will be a plus root of b. So you just change the sign. So that'll be the conjugate pair. Conjugate pair. So using the conjugate pair, I am able to eliminate the surd and get a whole number. Okay, so we're going to do some simple examples now. So 1 root 8. We need to simplify that surd. So root 8 will be root. So the largest perfect square in here will be 4 times 2. And that will give us root 4 times root 2, which is 2 root 2. So root 8 has an exact value of 2 root 2 in its simplified manner. So we're simplifying now. Now root 24. Okay, so the largest square, well, 24, that would be 4 times 6. So 4 times 6 would be root 4 times root 6, and that would be 2 root 6. So that's 24. Let's try 63. So that'd be square root. Well, so 63, if you're not sure, you could always use your calculator actually to help you in this case to do your multiplication. So 63, what two numbers can you multiply by 63 to get 63? So, I mean, you could try 63 divided by 2, but 2 wouldn't go in there, so you get decimal. You don't want that. So 63, you could do 63 divided by 9, might be a good idea. 7. So that might be the highest square, the perfect square you could get is 9. So it would be 9 times 7. So that's one way of checking it. You have to find a perfect square. So that would be root of 9 times root of 7. And that will be 3 root 7. So that's 63. What about 72, sorry. So root of 72 will be, again, 72, I'm looking at, well, 72 divided by, 2 will give me 36. So that's good because highest squared I can get is 36. Perfect square. Okay, so I will get root 36 times 2, which will be, right, so I'll get root 36 times root of 2, and that will be 6 root 2. To express in k root x, where k and x are integer. So where k and x are integer, so k and x are integers. Okay, so we've got root 20 plus root of 5. So the root of 5 is a clue. We can write root of 20 in terms of root of 5. But 20, root 20 is 4 times 5 plus root 5. And that will give root 4 times root 5 plus root 5. And that would be 2 root 5 plus root 5. 2 root 5 plus root 5, that's like saying 1 root 5 plus 2 root 5. 2 oranges plus 1 oranges is 3 oranges, so that would be 3 root 5. So k equals 3 and x is 5. K equals 3, x equals 5. Root 32 minus root 8. So root 32 will be 2 times 16, and root 8 will be 2 times 4. So that would be root 16 times root 2. 16 times 2 is 32. Minus, let's put that in square bracket, minus root 4 times root 2. So that's what 8 is 4 times 2, 16. So I can see that that would be 4 root 2 minus 2 root 2, and that will give 4 minus 2, so that would be 2 root 2, where k is 2, x is 2. So now we're going to expand 1 plus root 2 multiplied by 2 plus root 2. So we're just basically going to expand. And to expand that, so this is expand. So that would be 1 times 2, that would be 2. 1 times root 2 would be plus root 2. Root 2 times 2, that would be plus 2 root 2. Root 2 times root 2, that would be 2. So that should give us, that would be 4. 1 root 2 plus 2 root 2 will be 3 root 2. So that would be 4 plus 3 root 2. 1 root 2 plus 2 root 2 is 3. 1 oranges plus 2 oranges. Let's assume the root is an orange. That'll be 3 oranges. So that's 4 root 3. 4 plus 3 root 2. Let's do the more expansion on this side. Lots of space. So I have 9 minus 2 root 5, expanding that with 9 plus 2 root 5. Oh, so that it's a conjugate pair, because that's minus 2 root 5 and plus 2 root 5, and 9 and 9 the same. So we should be expecting to get 9 squared. Minus times minus is minus. So that'd be minus. Now, well, so minus that 2 root 5 times 2 root 5 will be 4. Root 5 times root 5 is 5. 4 times 5 is 20, so that'll be minus 20. And the answer should be 9 squared is 81 minus 20, and that would be 61. But let's prove that, see if we get that right. So we would do 9 times 9, that's 81, just to create more space. 81, 9 times 9 is 81. 9 times 2 root 5 will be 18 root 5, that's a plus, minus 2 root 5 times 9, that'll be minus 18 root 5, so that cancels out. Then we got minus 2 root 5, so that's minus 2 root 5 times 2 root 5, so that will be minus 4 root 5 squared, which is 4 times 5. That's how we get 20. So that's 81 minus 20, and that will be 61. But you got to be careful not to fall into a trap. So if you have 3 root 5 minus 4 squared. Now this is different because you got 3 root 5 minus 4 times the same thing, 3 root 5 minus 4. So there's no conjugate pair here. And so what we need to do is to just multiply them out. 3 times 3 is 9. Root 5 times root 5 is 5. 9 times 5 is 45. And 3 root 5 times minus 4 is minus 12. Root 5 minus 12 root 5 minus 4 times 3 root 5 will be minus 12 root 5 minus 4 times minus 4 is plus 16, and that would be equal to, now we got 45 plus 16, so so that'll be, just add 45 and 16, that'll be 61. Well, we got minus 12 root 5 minus 12 root 5, so that'll be minus 24 root 5. And that'll be your answer.